Hi guys, welcome back, and in this video I will be covering more problems on pair of straight lines, specifically talking about angle between a pair of straight lines. Okay, so let's look at the first problem. So we have to find the angle between the lines given by the following equation. So let me write it down. Lambda y square plus 1 minus lambda square, so 1 minus lambda square times xy plus minus lambda times x square is equal to 0, of course. So first of all, just notice the general pattern here. This definitely represents a pair of straight lines, and if you are wondering why, well, just compare this equation with the general form of a pair of straight lines, which is ax square plus 2hxy plus by square is equal to 0. Now you can clearly see that this is a specific case of this. Hopefully that makes sense. Okay, now we have to calculate the angle between the lines. Okay, so for that we have this formula: theta is equal to tan inverse 2 square root of h square minus ab divided by a plus b. And now we have to calculate a, b and h. So let's do that. We are just going to compare these two equations. So let's say this is equation 1 and this is equation 2. I want to divide both sides of equation 2 by a so that I can compare this easily. Actually, no, we don't need to, because you see in this equation the coefficient of x square is something, it's not 1, and same is the case with this equation. So we have coefficients in for each of the terms, so we don't need to divide. We can simply just compare these two equations. So let's do that. We'll get, so first of all let's compare the coefficients of x square term. So it's going to be equal to a is equal to, and in this we have minus lambda, so minus a is equal to lambda, right? We got the value of lambda. So far so good. Let's compare the coefficient of y square term. In the second equation we have y square is equal to b. Let's see what that is equal to in the first equation. Well, it's equal to lambda. Okay, now this is interesting. So what that means is that a is equal to b, because lambda is equal to minus a and lambda is equal to b. Basically that means b is equal to minus a, because it has to be the case. And then finally let's compare the xy term. We have 2h is equal to 1 minus lambda square and h is equal to 1 minus lambda square divided by 2, right? Now let's see. We have lot of flexibility in this question, because we know that lambda is equal to minus a, lambda is also equal to b, and h is equal to 1 minus lambda square divided by 2. But in order to solve these types of questions, we have to express everything in terms of just one variable, so one constant if you will. So let's say we express everything in terms of b for simplicity. So let's say that, even though you can do that in terms of like a also, it doesn't matter. It's going to be equal to tan inverse, theta is equal to tan inverse 2 h square. Now what is h square? Well, it's just equal to 1 minus lambda square divided by 2 whole square, right, minus a times b. Well, b is just b, and a is equal to minus lambda, which is equal to minus lambda is just equal to minus b, so it's equal to b square, right? And then we have a plus b, so b is just equal to b, a is equal to minus lambda, which is equal to minus b. Now this is interesting actually. So we see that denominator is getting 0. What that means is that if this is 0, we know that from basic trigonometry that theta is approaching 90 degrees. So this is the answer to this question, and let me verify if that is the case. I want to confirm that from my textbook. That's right, the lines are perpendicular and the angle is 90 degree. Okay, I want to move to the second problem, but I think I'll do that in the next video. So thanks for watching this video.